So let's look at some of the basics of network intrusions, and especially around using intrusion detection systems such as snort. Okay, so we'll look at a basic introduction to IDS systems, some basic terms that we normally use when we use IDS, look at some outlined threats that an IDS is particularly useful for. We'll look at the different types of IDS systems, then we'll look at whether we use a host-based IDS or a network-based one, and then we'll look at a practical example of a package, an open source package called snort, and look at a very simple rule for using snort. Okay, so what is IDS? Let's have a look at some basic terminology that we often use in terms of network security. Many of the terms that we actually use actually derive themselves from a military type environment, and in a military environment we often use the term defense in depth. And defense in depth is all about adding multiple lines of or layers of defense. And it's often that we use lightweight defense as a first level, heavier as we go to second, and then on to third, and then the fourth level defense is the heavy military equipment as we see here. And that's often used in a security context too, where we might use some lightweight security at the front end, such as a firewall, and then we might use other types of defense systems, and then eventually we might use some heavy duty defense really as the fourth level of defense. Good thing with this type of model is that the security at this level can be fairly lightweight and doesn't really get in the way too much for our users and our data. Another thing that happens in this multi-layered defense is that it can take some time to breach each of the layers as an intruder goes through them. If we have the 4 of the same layers, then the intruder breaks one and then easily breaks the other 4. So we often have different challenges for an intruder, and then what we want to be able to do is to be able to detect when an intruder goes into each of these layers. Another concept that we have in terms of network security is that we often have a 3-leveled system or 3-zone system. When we buy a firewall, often it has 3 ports. We have one which connects to an untrusted side, that's onto the internet. We have another that connects to our side, that's the trusted side. And then in between we have the place where these two can actually meet together, and that's within a demilitarized zone or a DMZ. And this tends to have a lesser security, so we can put a lot of our servers, our forward-facing equipment in this area here, so that it can be easier for someone to create an intrusion in this area, but the security we have over here is much heavier. Okay, so this gives us our 3 main classifications: trusted, untrusted, and DMZ. And unfortunately what we have is that every system can really be broken in some sort of a way. So it's very difficult to place barriers up to stop every intrusion from happening. And we really want to try and protect our users, our assets, our data, and our system from intruders. So an IDS system, or intrusion detection system, places little agents within inside each of these layers, and it is the focus of the IDS system to be able to pick off something that doesn't look quite right. It might be an anomaly, or it might be a well-known worm or a virus spreading over the network, or it might actually be a user installing a piece of malicious software on a host. So we can set up IDS throughout our system into all the different levels of our infrastructure. Now we'll look at some threats that we can detect with intrusion detection systems. Okay, and so unfortunately there are so many threats that that currently exist with inside network systems. We have data stealing, an external hack, denial of service, personal abuse, worms and viruses, fraud, terrorism and extortion, and so on. And our challenge from a corporate point of view is to make sure that the firewall stops all these things from getting in, but also allows us to be able to access external systems such as web, email and corporate access. So we typically define a network perimeter, and this is normally the only way that you could get in and out of the organization is through the firewall. So no data can leak out, and intrusions are easier to deal with if we can have a single gateway out of the whole of the corporate infrastructure. Then behind that we can have our users, systems, data and assets. These are the things that we're actually protecting. Along with that we might have our intrusion detection system just in case someone gets over the firewall. CIS, the Computer Security Institute, has actually found that most of the breaches actually come from insiders inside the network, so that the network firewall cannot defend against an inside threat. Okay, so this shows a very simplistic architecture for a corporate type network we have outside here. This is the main gateway here, and then we might have a firewall here, and the firewall is splitting our traffic into three: our untrusted, our trusted, and this is our DMZ. So we would place our corporate servers within inside a DMZ, and then all our users might be behind a network address translation device, which will make all the addresses private here. So it's all very difficult for someone to get access to a device behind NAT. So in terms of our defenses, we're running a firewall here, we're running NAT, and we're also running intrusion detection systems. So this one here listens to threats that are coming in and could be blocked by the firewall. This one over here is listening to the DMZ and all the traffic here, maybe picking up intrusions that happen in the DMZ. This one is possibly looking at insider threats, where we have an IDS system which might trigger on an insider threat. And then we might even have our devices running IDS systems. Here we see a firewall here, and that's also protecting the internal users. Okay, so this shows really a whole lot of defense in depth methods: firewalls, NAT devices, IDS, DMZs, and so on. What are the different types of IDS systems that we actually get? They normally split into two main categories, and that's ones that do misuse detection. And with misuse detection, we're looking for standard signatures of viruses and worms, a standard sign of a denial of service attack, and some sort of external scripting. So this type of IDS is useful for standard types of attacks. It could be done by script kiddies or from well-known worms and viruses. So if a system is well patched, it will have the most up-to-date signatures for detecting the most up-to-date worms and viruses and malware. And for denial of service, we're looking for the standard type of attack that would typically come from a script. So they're very good at detecting well-known attacks, but unfortunately they're not so good at detecting human type attacks against a system. The other type is more focused on detecting possible human intruder behavior, and that is anomaly detection. With anomaly detection, we look for normal types of activity and then try to detect when something is abnormal. So it could be that the number of accesses to a database, to a certain database, is 10 per day, but all of a sudden it becomes 1,000 per day. Or the amount of FTP traffic on the network increases by 20%. So that can be an anomaly. And this type of system is quite good at detecting things like data stealing, an external hack from a human, fraud, and personal abuse. Along with that, there are other types of IDS type systems that we classify. We can have a network intrusion detection system, and with this one we monitor the network packets on a system and then try to listen to see for any patterns of intrusion. We can have a system integrity verifier, and with this we have the concept of an agent which monitors certain files. A good example of this is Tripwire. Tripwire is informed as to a number of files which it watches, and then if someone accesses any of these files, it will create an audit for it and alert someone. So it could be also for monitoring the Windows registry or root and administrator privileges. We also get log file monitoring, because our logs could be spread across many servers on the infrastructure. So we might see an attack on our web server, but also see a presence with inside email in our database system and so on. So log file monitors look across the whole network and look with inside log files to see if they can actually determine if there is any activity across the whole of the network. And then we also get a method called the user profiling. With user profiling, we actually try to get the profile of a certain user and then try to define that as a basic profile. So for example, we might detect that a user types at a certain speed, and then if a user logs on and they don't type at that speed, such as say that they type at 30 words per minute and all of a sudden they go down to 10 words per minute, it could be someone logging in on their behalf. The key focus of an IDS system is really to try and detect a threat at an early stage and close it and make sure that it does not happen again. So it's really looking at the behavior of what might cause a threat. And we normally go through certain phases with inside an intrusion. At the end phase is the profit, where there might be some data stealing or a server damage, user abuse and so on. And what we've got to try and do is understand the steps that an intruder might make to be able to get to the point of profit. So normally what would happen, we possibly would see some sort of outside reconnaissance. Difficult for us to know that that's going on, but it might be looking at public addresses, who is and so on, for DNS and IP information about the systems. Then with inside our network, the intruder might find out a little bit about where the subnetworks are, where the network devices are, and the hosts and so on. So that tends to be around inside reconnaissance, and we can typically see this type of activity, and hopefully we can detect it and stop the intrusion going any further. After this, we get to the point of exploit. So the intruder has found a loophole or a weakness in the system and tries to exploit it. So this might be breaching a firewall, cracking a password, and so on. This can often happen with unpatched systems, that the intruder actually can see there's a system that is unpatched and will try to use this vulnerability. After this, the intruder may get a foothold, maybe at a low-level access, and then move up through the different levels to gain a foothold onto the system, then move on to profit. So it really goes from this yellow to red, and what we need to do with IDS systems is at each stage we really try to detect that something is happening. Along with the concept of the different types of IDS, we either get ones that really focus on a host or a single machine or on network traffic. And with network-based IDS systems, they will typically look at a whole lot of traffic. So this might be streamed from the network for traffic that's interesting, and then the IDS will analyze that. Or we can install our IDS on a single host and it will monitor the network traffic for that actual host. Okay, so here we go. We can have IDS systems that will run on each of our servers here, and then on this host over here. Then we have IDS systems analyzing network traffic. If we want to monitor network traffic, then we would often use a hub. A hub is used where we want to monitor all of the ports. So in this case, the hub this IDS will be able to pick up all the traffic across the whole network. Unfortunately, a switch does not operate like this, and the IDS system cannot hear the traffic from the other networks unless we set up a special span port operation. In this case, we're on a Cisco switch, and we actually define on the interface that the device is on, we actually define a port monitor. In this case, we're monitoring port 2 and port 5, and also a virtual LAN of 2. So this interface and this interface are monitored, and because this interface and this interface are in a virtual LAN, they will also be monitored. In this case, what will happen is that we will interface 1, 0, 1 will actually get all the traffic that's destined for these ports. Okay, so our IDS often have different objectives. This IDS here is detecting against attacks against a server. This one here is detecting against attacks against a host. And this one here is detecting against internal attacks. This one here is detecting against attacks against the main firewall, and this one actually, because some of the intrusions could be detected, blocked, this one is detecting any successful breaching of the firewall. So let's look at a real-life IDS system, which is Snort, which is one of the most successful open source packages for intrusion detection systems. And Snort is made up by having what's called an agent. We run our agents on different systems. It could be on different types of hosts, Linux or Windows. Each agent will read in the rules for them, and these will have well-known patterns of activity. We can also use it for anomaly detection if we want, but it's typically used within signature detection. And Snort will then read the rules and then create an event data and then also a log. So an event data could be that there's a denial of service attack ongoing, and then we could look at the log to see the detail of that intrusion. Other tools that we could use is TCP trace and TCP flow, which can actually play back and identify TCP streams. The rule itself looks a little bit like this. What we have at the start is that we can either just log or we can create an alert. So we have an alert file called alert.ids, and this will create an alert in the alert file when this rule is fired. We could log it, we could ignore it if we want. The second part actually defines the protocol that we're going to use, TCP, IP, and so on. After this, if we use TCP, we actually define the source IP address and the destination, the source IP address and the source port, and this arrow identifies that the packet is going to, and in this case we select a network, certain network. This defines, 24 defines the first 3 fields here. 192.168.1 is the whole network, and we ignore the last part. and this is the destination port that we're interested in. We can then define the content that we're looking for. In this case, we're looking for a certain binary pattern, and then the message that we want to be displayed when the rule is triggered. At the end, each rule must have its own unique SID. Snort has defined a range of these, so every time a new threat comes out, then they'll give it a new SID with a certain revision number. So for example, SID 336 revision 7 is an attempt for the administrator account on an FTP server. So we can use our own local rules if we want. So in this case, we're using a standard rule here, and it's SID 1991 revision 1. We can see here what this one is doing is listening for user in the data packet. So let's look at a simple snort rule. Okay, so the very simple one, all this is we're detecting any traffic from our network going to anywhere with the content of the word the, and we give a message. Okay, so we'll just give this a try. So I've downloaded snort. The main executables are in the snort bin. Obviously what you need to do to run the command from anywhere is that you would go to your environment variables, and for the path we would just enter wherever we've created snort, and then when we run our command line we'll be able to use the command snort. Okay, so I've set up a folder called new, and the first thing we often have to do is to be able to determine which interface we're going to capture on. So we get something like this, and what we've got to do is to try and make some sort of sense of this, to find out. We could go through each interface, but let's actually try and find the interface that we're interested in. And we can usually do that from here. So we can actually see, in this case, if we look at the MAC address, or the IPv6 address, 445.2b39. So we'll snort list interfaces again, and here we are here, 445.2b39. So that is interface 3. Okay, so I've set up a simple batch file here. So snort -v is verbose, -e will give us the Ethernet details, -e will give us ARP, and then -i is our interface number, -3. We then define a rules file. We have L, -l will log to a certain folder, and -k, ASCII, will create ASCII or text logs. Okay, so let's have a look at our rules file. So the first thing you would do is to create your folder. Mine is already created, and let's make sure it's empty. And it is. So let's try a simple row. Okay, so in this case we're going to detect any traffic going to port 80, going to a web server with the content of the. So it's a capital TH here, and then we'll put the message that found give it a unique ID. So these have been commented out, and we'll come back to them later. Okay, so I'm going to run this now. Doesn't like the -a option. So let's take it out. It used to be, -a used to be on snort, and it would give you ARP information, but it isn't anymore. This is unfortunate. So we see that, and if you want, you can get rid of that by just getting rid of the verbose option. Okay, so what we'll do is that we'll go and just go to Google and we'll search for the, and hopefully we should have an intrusion detected. Unfortunately we haven't, so let's go again. Let's just check our rules. So we're going to port 80, content of the, and that's the message. Okay, so this time we do have an alert. So we can see we have one alert there. It should show us the amount of packets we've captured. And now this time, so this is the packet here. So we can see the source IP address and the destination one, which is probably this one here, IP address for this site. Okay, so that shows a very simple example. So we see with inside the log will actually give us details of the MAC address, IP address and TCP part. So if we look at the detail of our log will show the source and the destination MAC address. So here we go, source, and then there's the destination MAC address. So in this case it's likely to be the MAC address of the gateway that we're dealing with. 800 here means that it's an IP packet. In the next part we see the IP address in here. This is the source IP address, destination IP address, the type is TCP. Within the IP, there's the TTL field, the length, and so on. And then for the TCP part, we actually see the source port, destination port, and then there's the flags, and this is acknowledge push. And then what we get is we've used the log option. It will log our data packets into a text format organized from the host, which is actually sending the data. So that should be in here. Okay, in this case there's just one stream, and it gives us that data. Okay, so the alerts really just give us all the alerts that have been triggered, where the log file will actually give us all the data packets that have been logged. So you can see in this case, we get a whole lot of these IDS files, giving us the port, source port, and the destination port. So this has logged all the traffic for this connection here. A key part of any connection is typically focused around the TCP flags: urgent, acknowledge flag, push, reset, sequence synchronize, SYN, we've seen SYN before, and then there's the FIN. Okay, so there's the standard connection that we get for three-way handshake. SYN sent, SYN received, we send back a SYN ACK, and then we get an ACK coming back from the client, which will make the connection. And it's the SYN that often identifies the start of a connection. Okay, so there's an example of a log where we can see the SYN ACK from the server, and then the client responds with an ACK. Okay, so we've outlined a basic introduction to IDS and snort.